Welcome to Study Loop.
Hi, my name is Jeffrey, and we'll be doing a problem from section 1.1, number 6, from Stewart, 8th edition. In this section, we discuss examples of ordinary everyday functions. Population is a function of time. Postage cost is a function of weight. Water temperature is a function of time. Give 3 examples of functions from everyday life that are described verbally, and what can you say about their domain and range, and sketch a rough graph if possible. Okay, so I had to cook up 3 examples on my own, and one of them is going to include emptying a bathtub. Okay, so for number 1 here, emptying a bathtub is going to be a function of height over time. Okay, so height of the water as a function of time. Okay, so in our graph here, it looks like maybe if the height were to start at 24 inches off the ground, okay, and the water is going to drain at a constant rate, okay, until the height of the water is 0, okay, and maybe it takes 5 minutes for that to happen. Maybe it takes 5 minutes for it to happen. So it looks like we're going to have a linear graph here, and the domain of this function, we'll call it height, this height function is going to be the set of all x such that x belongs from time 0 to 5 minutes. And the range of the height function here corresponds to the vertical axis, the height, okay, we'll call it y, set of all y such that y belongs from 0 inches off the ground to 24 inches off the ground. And so for our second example, I thought of the temperature of an oven when baking cookies. Okay, so 2, we're talking about temperature as a function, temperature as a function of time. Okay, so I think home, it's usually around, the indoors of the home is usually around, I don't know, 74 degrees. I'll say 74 degrees, and as it's preheating maybe at a constant rate here, it needs to preheat up to 350 degrees, and maybe it takes, I don't know, 10 minutes for that to happen. Okay, and we're baking cookies for, I don't know, let's say 20 minutes. Okay, so it stays at the temperature of the oven stays at 350 degrees for 20 minutes, and then it needs to cool down all the way back to room temperature, which is 74 degrees. And maybe it takes like just as much time, so maybe this is 50 minutes there. Okay, so maybe it takes 20 minutes for the oven to cool down. So let's talk about the domain of this temperature function. Okay, and that's going to be the set of all x such that x belongs from 0 to 50 minutes. And the range corresponds to the temperature of the oven, okay? And so I guess the temperature of the oven belongs from 74 degrees all the way to 350 degrees. And for this last one here, I said riding a bike down the street, okay? Riding a bike down the street. So this is a function of speed over time, okay? So speed is a function of time, speed versus time. And so when I ride my bike, I need to start at, my velocity starts at 0, obviously, and I need to accelerate a little bit. So maybe I take off like this here, and I reach a top speed of, I don't know, 20 miles per hour. And maybe I stay at 20 miles per hour, and maybe I can get a little bit faster than that. But then at the end of the street, I need to stop at the stop sign, so I need to go to a halt there. So the domain of this function, we'll call it the domain of speed function here, s, is the set of all x, okay, representing time, such that, and maybe, so maybe this takes, I don't know, 3 minutes for all of this event to happen. So x belongs from 0 to 3 minutes as I ride my bike down the street, and the range corresponds to how fast I'm going, the speed, okay, is the set of all y such that y belongs from 0 miles per hour to 20 miles per hour. Thank you for watching.